Hello everybody and welcome back to day 3 of our week 16 triangles and circles. Today we are going to do day 3 of our week 16, which are pages 3, 8, 11 and 15. So these are the 4 pages that we are going to take on today. All right, so we will start with page 3. And so I will turn to my chart because the first thing they're asking us to do is to study our cosine waves or the cos waves. Study domain theta. Theta belongs to real numbers, which we already know. The real numbers are all the numbers except imaginary numbers. Period of 360 is 2 pi. Here you have simplify even symmetry. So far we saw sine, we saw tan as well, I think, but those were odd symmetries. The first time you're seeing an even symmetry is in cos. So even symmetry, cos of negative theta is cos of negative 90, which is cos 270. So negative 90 is actually 0 here. When theta is 0, cos theta is when theta is 90, cos theta is 0. So cos 270 is also 0 because negative 0 is 0. And then it equals, so cos of negative theta, what they're trying to say is cos of negative theta is cos theta. Remember this because this is going to be important. In the previous examples, we saw that cos of or sine of negative theta would be negative sine theta. Not so with cos. Okay, so this is a very significant thing that we have to remember right off the bat, because this is gonna help us avoid a lot of confusions when we solve for theta when it comes to cos theta. All right, let's move on to this side of the cosine wave study. So we're studying theta and cos theta, and we're going to sketch theta, the cos theta, using degrees and radians. All right, so cos 0 here is 1. When the angle is 0, we have the cos theta becomes 1. When the angle is 45, it becomes square root of 2 over 2, which is slightly less than 1. When cos is 90, it becomes 0. When cos is 135, which is negative 45, it becomes negative square root of 2 over 2. When it is 180, it is negative 1. When it's 270, it is 0. They've skipped an angle here, 225. But 270 becomes 0, it goes up again. And then finally, when it reaches 360, let me zoom in, I'm sorry. Okay, when it reaches 360, it becomes 1. So the graph moves all the way up over here. Okay, all right. All right, so you already know this is 0. Okay, all right, read the equations aloud, simplify the sums and differences. So where this comes from is, if you take out your charts and look at chart, let me zoom out. If you look at chart 16.3, which is your third page of your chart, it's right smack in the middle of the booklet, you'll see that there are some advanced formulas for finding derivatives and integrals, and these are some advanced formulas. We do not know how, we do not need to know how they arrived at these formulas or what was the logic used. They've just given us the formulas and they want us to use these formulas as they see fit. So we are just going to use it just like they say use it. So I'm going to read the equations aloud and then we're going to simplify the sums and differences. All right, so cos of theta plus beta, or beta, is cos theta times cos beta minus sin theta times sin beta. Okay, they have already mentioned that your theta is 0 and your beta is 45. So you're just going to substitute for 0 at wherever theta is found and 45 wherever beta is found. So cos theta is cos 0, cos beta is cos 45, minus sin theta is sin 0, sin beta is sin 45. So I'm just substituting for theta and beta here in this equation, okay, with 0 and 45. All right, so cos of 0 plus 45. So remember our PEMDAS rule, 0 plus 45, you solve for what's in the parenthesis first. So now we have cos 45 equals, okay, now we solve for cos 0 and cos 45. So even from here you can see that your cos 0 was 1, so they've written 1 here. Your cos 45 was square root of 2 over 2, okay. minus, now you're solving for the sine part of it, your sine 0. So remember, you can flip the pages back, or you can just go to, on chart 1, you have your sine values here. Okay, your sine 0 is 0, and your sine 45 is square root of 2 over 2. Okay, so I'm just going to substitute that here, 0 dot or times square root of 2 over 2. Okay, let's solve for what's inside the brackets or the parentheses. So negative, the left hand side, we already know cos 45 is square root of 2 over 2. So they wrote that down. That equals, what is 1 times square root of 2 over 2 is just the same, minus 0 times anything is 0. So minus 0. So we see the left hand side equals the right hand side. Therefore, it's true. All right. Moving on, let's do the same thing that they did here. Okay, for sine of theta plus beta. So sine of theta plus beta equals, again, I'm not making this up. This is already what is given. So sine theta cos beta plus cos theta sine beta. Okay, sine of 0 plus 45. Again, I'm referring to this chart. 0 plus 45 sine is square root of 2 over 2. So I'm just going to write, they've already written that down for you. So you don't have to solve anything on the left hand side. Your sine 0, as you already know, is 0. Your cos 45, from here, you see it's square root of 2 over 2. Okay. Plus your cos 0, from here, you know, it's 1 dot. What is your sine 45? We just figured out it's square root of 2 over 2 from here. Okay. Okay, so this entire term goes away because it's 0. And then you have plus 1 times this, square root of 2 over 2, which is square root of 2 over 2. Or 1 times square root of 2 over 2, which is square root of 2 over 2. Okay, so your right hand side is equal to the left hand side. All right, here's another formula. Tan of theta plus beta equals tan theta plus tan beta over 1 minus tan theta tan beta. Okay, tan of 0 plus 45 is tan 45. How do I know tan 45 is 1? You can refer to this chart here. Okay, tan 45 is 1. Okay, so that's what they've already done. Now let's look at what is tan theta. Tan theta here for me is 0. Tan 0. Tan 0 here is 0. Again, I'm looking at all these values from here, from this chart here. Tan 0 is 0. Okay. Tan beta is tan 45. Tan 45, as I already know, is 1 over 1 minus tan theta is 0 dot tan beta is, or tan 45 is 1. Okay, so 0 plus 1 over 1 minus 0 times 1. Okay, 0 plus 1 is 1 over 1 minus 0 is 1. So my 1 equals 1. Okay, I hope that was clear. Right, moving on. Let's solve for cos of theta minus beta equals cos theta cos beta plus sin theta sin beta. Cos of 0, again your theta is 0, your beta is 45. So let's just look at the left hand side for now. So cos of 0 minus 45 is cos of negative 45. Remember what I said here, cos of negative theta is the same as cos theta. So we're going to treat it as cos 45. Okay. This is only in the case of cos theta because it's even symmetry. When there's odd symmetry involved, we don't do this. We just say negative cos theta. So that's a different thing. But here we already have, they've already explained to you, don't get tricked. Cos of negative theta is the same as cos theta. So we're going to treat cos of negative 45 as cos 45. Okay, so go back here and look at your chart, the unit circle. So cos 45 here is square root of 2 over 2. If it was an odd symmetry, I would have gone for this and I would have written negative square root of 2 over 2 for negative 45. But as I already mentioned, it's even symmetry, so we're going to treat it just like cos 45, and we're just going to write, they have already written it for you, square root of 2 over 2, even though it's negative 45. Okay, moving on. So the left hand side, they say, is square root of 2 over 2. The right hand side says cos 0. What is cos 0? Let's look here. Cos 0 here is 1 dot cos 45 here is square root of 2 over 2. Okay, plus what is my sine 0? I'm going to look at my first page chart. My sine 0 is 0. Okay, and my sine 45 is square root of 2 over 2. Okay, so 1 times square root of 2 over 2 is square root of 2 over 2, plus 0 times anything is 0. So hence my left hand side, which is square root of 2 over 2, is equal to square root of 2 over 2. Okay, all right, we've done that one. Sine of theta minus beta is sine theta cos beta minus cos theta sine beta. So sine of 0 minus 45 is sine 0 cos 45. They've just substituted for the theta and beta again, minus cos 0 sine 45. Okay, sine of 0 minus 45 is sine negative 45. Now this is different. Okay, this is odd symmetry. So where there's sine of negative 45, I'm going to treat it as negative sine 45. Okay, so my negative sine 45 at the unit circle would be here, 135, right? So that would be square root of 2 over, negative sine 45 would be, this is my bad. Negative sine 45 would be square root of 2 over 2, but negative of that would be negative square root of 2 over 2. Okay, so I'm going to say negative square root of 2 over 2 dot cos 45. What is my cos 45 here? It says square root of 2 over 2. Okay, minus cos 0 is, where is my cos 0? Cos 0 is 1, right? And my sine 45, my sine 45 is square root of 2 over 2. Okay, so this gives me 2 square root of 2 times square root of 2 is 2 over 4 minus square root of 2 over 2. Now I have a feeling I made a blunder here, so let me look and see what I did. Oh, I don't know why I look for sine 45. This is sine 0, right? I've been looking for sine 45 here. My bad. All right, so sine 0 here is 0. Sorry. So this entire term becomes 0, and then I have negative, right? And I have negative 1 times square root of 2 over 2. So that is just negative square root of 2 over 2. Okay, so my negative square root of 2 over 2 equals negative square root of 2 over 2. I'm sorry about the sine 0. I assumed it was sine 45 somehow. I don't know how. But mistakes happen and we move on. All right, tan of theta minus beta is tan 0 minus tan of 0 minus 45 equals tan theta. I'm going to be super careful now. Tan theta is tan 0 is 0. Okay, minus tan beta, which is tan 45. Tan 45 is 1 over 1 plus, what is my tan theta? 0. What is my tan beta? Tan 45, 1. Okay, so they already told me negative 45 is negative 1. So here I have 0 minus 1 is negative 1 over 1 plus something, 1 plus 0, and 1 plus 0 times 1 is 1 plus 0. So I have negative 1 over 1, which is negative 1. Okay, we are on page 7, secant waves. So if you look at, we're studying secant waves now. So our domain is theta. Theta belongs to real numbers when cos theta is not equal to 0. Okay, and this is all the values. Here again we have even symmetry. So we see that secant of negative theta is secant theta, just like the cos. Okay, so secant of negative 90 is the same as secant 90. Secant 270 is the same as secant 90. So secant 90 is it approaches infinity, and secant 270 also approaches infinity. So I'm just going to write infinity on both sides. Okay, and then here they're asking us to compare theta and secant theta, sketch secant theta, and label the quadrants. Okay, if you have any doubts about sketching these wave functions, just go to your charts. It's on page 16.4. Okay, so you will see here secant theta is over here, and you will see how it's sketched out over here. So we can just like look at these for reference and just follow suit. Okay, I'm going to keep it here so you can see it. All right, so I have 0, my when my angle is 0, my secant theta is 1. So we start here, okay? And when my angle is 45, my secant theta is square root of 2. When my angle is 90, my secant theta approaches, as theta approaches 90, my secant theta approaches infinity, okay? So I'm gonna go this way, right? That's what it says. All right, moving on. So let me label the quadrants Q1, Q2, Q3, Q4. We've already gone over this in the previous yesterday's chapter about how to label the quadrants. All right, moving on. So as theta approaches 90 degrees, we approach infinity. And then when theta is 135, we are at negative square root of 2, which is here, okay? So this is secant theta, so this is our here, okay? So we know that as theta approaches 90, we are going towards infinity. So I'm going to put this arrow like this, okay? And then we're approaching square root of negative 2. And then as theta approaches 180, we are going to minus 1, so that's over here. And then when it becomes 270, okay, we are going to, again, infinity. So we are going this way, okay? So even though we're going this way, we also know that it can also go the opposite way, right? Because infinity is on both sides. So in your in the booklet, in the charts, they also mention how at 270 it's also going the other way. I'm sorry, at 270, see, the infinity function is also going this way, okay? So as theta approaches 270 plus, it is going towards positive infinity. As theta approaches 270 minus, it is going towards negative infinity, okay? All right, that's for sketching them. And now we are moving into advanced trigonometric formulas. Read the equations aloud. Simplify the double angle equations. Cos 2 theta is cos squared theta minus sin squared theta. So cos of 2 times 30, where your theta is 30, is cos 60. Cos 60 is half, so that's taken care of. Let's move on to the right hand side. They say cos squared of 30 is the same as cos 30 the whole squared, minus sin squared of 30 is minus sin 30 the whole squared. Cos 30 we know is square root of 3 over 2. How do I know that? Look at your unit circle, or you can look at your the first table here on your chart. Over here you have all your cos and sine and everything written here. Or if you're just more comfortable with the unit circle, just look at this unit circle and it'll tell you cos 30, sine, everything, okay? So cos 30 is square root of 3 over 2. You square that, minus sine 30 is 1/2. You square that. So square root of 3 over 2 squared is 2 times the same thing. All right, so square root of 3 times square root of 3 is 3 over 4, because 2 times 2 is 4, minus 1 times 4, okay? This is actually 3 times 3 quarters minus a quarter is 2 quarters, which is half, okay? All right, here we have sine 2 theta is 2 sine theta cos theta. So sine 2 times 30 is 60 equals 2 sine. Here you have sine 30 and you have cos 30, right? Okay, so 2 times of what is sine 30? From what I know, sine 30 is 1 by 2, okay, times what is cos 30? Cos 30 is square root of 3 over 2, okay? From here, you can easily see that these two 2's are going to cancel out, right? So you have 1 times square root of 3 over 2. So square root of 3 over 2 equals square root of 3 over 2, okay? Moving on. Here you have read the equations aloud, simplify half angles. Cos of 60 over 2 or theta over 2 equals plus or minus square root of 1 over 2, 1 plus cos theta. Do not be intimidated by these funny looking scary equations. They're not as bad as they look. You just have to substitute and just keep calm and carry on, okay? So cos of 60 over 2 is cos 30. 1/2, 1 plus cos 60. Cos 60 is half. So 1/2 of 1 plus half is, so if you just worried about how they got this 3 over 2, you know, you can, this is just like fractions and adding fractions. Your denominator is 2, so it's 2 plus 1, because 2 goes once in 1, and so you just like, or you can just do 1.5. This is a mixed fraction, and then if you convert into a proper fraction, it is 2 plus 1 is 3 over 2. So that's how they call it 3 over 2. So square root of 3 over 2 equals plus square root of 1/2 times 3 over 2, which is square root of 3. This is actually square root of 3 over 4. So what they've done is they've kept the square root of 3 on top. Square root of 4 is 2, right? Because 2 squared is 4. So they've taken the 2 out, and that's how they got this 2 here. So it's plus square root of 3 over 2. So left hand side equals right hand side. All right, now they're expecting us to do this. So the left hand side has already been done for us. I'm going to go with plus or minus square root of 1 over 2 minus 1 over 2 of 1 minus cos. What is my theta? My theta here is 60. So what is my cos 60? My cos 60 is 1/2. Okay, so I have plus or minus square root of 1/2. What is 1 minus 1/2? Is half, right? Take away half from 1, you have another half. Okay, this is square root of 1 over 4. Okay, so square root of 1 is 1, square root of 4 is 2. So my left hand side equals my right hand side. Okay, compare, is sine squared theta the same as sine theta squared? Let's look at C16.3. If you look over here in the middle of the page, it tells you very clearly sine squared theta is sine theta the whole squared is the same as sine squared theta. It is not equal to sine of theta squared. Okay, so they're telling us here sine squared theta is sine theta the whole squared, which is right. Okay, cos squared theta, is it cos theta the whole squared? Yes, so I'm going to put equal. Is sine squared theta is not equal to sine theta squared. They've already told us that here, right? Sine squared theta is not equal to sine theta the whole square. Cos squared theta is also not equal to cos theta the whole square. So cos squared theta is not equal to cos theta the whole square. Okay, that was simple. Moving on to the next page, which is page 11. Okay, cosine waves. We're again studying cos waves. Again, it's the same thing. We've already gone over this. We've already gone over the exact same thing. We know cos 270 is 0. We know 90 is 0. They're just looking at the waves here, and they're asking us to fill up the table. Cos 0 is 1. Cos 45 is square root of 2 over 2. Cos 90 is 0. 135 is negative square root of 2 over 2. 180 is 0. 270 is again 0. I'm sorry, 180 is negative 1. Negative 1. 270 is 0. And 360 is 1. Okay, all right. All right. Simplify the product to some equation. Read the trigonometric identities aloud. Again, they have given us a bunch of equations. Substituting, we're going to substitute for theta and beta. Theta is 15, beta is 75. So 2 cos theta times cos beta equals cos of theta minus beta plus cos of theta plus beta. And then they've just substituted. Wherever you see theta, put 15. Wherever you see beta, put 75, right? So 2 cos 15 times cos 75. They've already given you the values of cos 15 and cos 75. Cos of 15 minus 75 is cos of negative 60 plus cos of 90. Okay, I'm going to look at my trigonometric circle and figure out what is cos 60. Cos 60 is half. So here it is, cos of negative 60 is still going to be half. Remember, it's even symmetry. Cos of negative theta is cos theta, so it's still going to be half, plus what is my cos 90? Cos 90 for me is 0. Okay, so 0.5 is half. All right, I don't have to do anything much here. All right, Moving on to the next one. 2 sine theta times sine beta equals cos of theta minus cos of theta plus beta. Substituting for theta is 15 and beta is 75. Again, I have cos negative 60 minus cos 90. My cos of negative 60 is again half, minus cos 90 is 0, half, which is the same as 0.5. Okay. So see, it looks so complicated, but it's really very, very simple. All right. So cos theta plus cos beta equals, simplify the sum to product equation. This is sum and it's turning into a product. Okay. So 2 cos of theta plus beta over 2 times cos of theta minus beta over 2. All right. Cos 0 plus cos 90, 1 plus 0. They've already solved the left hand side. I'm going to just substitute for theta and beta here. So 0 plus 90 over 2 times cos of 0 minus 90 over 2. So this is 2 cos, what is 90 over 2? 45 times cos, what is negative 90 over 2? Negative 45. Okay, so 2 times, what is cos 45? Let me look at my unit circle. Cos 45 is square root of 2 over 2. What is cos of negative 45? It is still going to be square root of 2 over 2. Remember, odd symmetry. Okay, so this is 2 times square root of 2 times square root of 2 is 2 over 4. Okay, so 2 times 2 is 4, multiplying the tops, over 4, which is 1, because these two cancel out. Okay. All right. Sine theta plus sine beta equals 2 sine of theta plus beta over 2 times cos of theta minus beta over 2. Okay. Sine 0 plus sine 90 equals 2 sine, my theta is 0 plus 90 over 2 times cos of 0 minus 90 over 2. So 2 times sine 45 times cos of negative 45. Okay, so what is 2 times sine 45? My sine 45 is square root of 2 over 2 times, what is my cos of negative 45, which is the same as cos 45, is square root of 2 over 2. So 2 times square root of 2 times square root of 2 is 2 over 2 times 2 is 4. 2 and 2 is 4, and I cancel that with 4 and I'm left with 1. Okay, and that completes page 11. Down to our last page, and we are at secant waves. Secant is the inverse of cos. Again, it's even symmetry. Again, secant of negative theta is secant theta. So I'm going to just go ahead and write so you know, for secant theta, let's just look at our table here. I'm on chart 4, C16.4. Okay, and here you see that as theta approaches 90, secant theta approaches infinity. Okay, so I'm going to write secant theta is infinity, and as theta approaches 270, as theta approaches 270, secant theta approaches infinity again. So both are infinity. Okay. Okay, all right, let's fill in these blanks here. Complete the table that describes secant theta and label the quadrants. All right, let's complete this table. 0 is 1 from here. I see that it's 1. Okay. 45 degrees is square root of 2. As theta approaches 90, my secant theta is approaching infinity. Okay. As as theta is 135 over here, I see that it's little more than negative 1, which over here for them they have mentioned it should be square root of 2, right? Because, or negative square root of 2. Negative square root of 2 would be 135. And then as theta becomes 180, I see that my secant is negative 1. Okay. And then as theta approaches 270, I'm approaching infinity because the line goes down like that. And as theta approaches 360 over here, you see that it's again 1. Okay, so it's positive 1. Okay, so my range here, well, let me label the quadrants, Q2 here, Q3 here, and Q4 here. And look at the secant theta. The range is from -1 all the way to secant theta is greater than, look, it's going down to -infinity, right? So secant theta is greater than -infinity, but less than -1 over here, right? And then on the top of your axis or your 0 line, you see that secant theta is less than or equal to 1. This is your lowest limit, and your highest limit will be infinity as it goes up. So it's positive infinity. Okay. All right. Draw 4 separate interior triangles. This is again advanced trigonometric formulas, but they are just asking us to go ahead and draw the interior triangles of this triangle here, and they're asking us to label the vertices and sides. So let's look at the first one. They've done it for us. A, E, C. This is our first triangle. Okay, so just block out everything else and focus only on this triangle, and you'll say the vertices are A, E, and C, and the sides are B, H, 2, right? And this, we don't know what the length of this is, but they're saying it's a measure of the line segment AE. Okay, all right, let's go to A, D, and C. So this, we're focusing on this triangle, so I'm just going to draw it here. 1, 2, 3 lines. A, D, C. And this is my right angle. Okay, and this is H1, B, and I'm going to write this is a measure of the line segment CD. Okay, all right, moving on. E, B is B, E, B, and C. E, B, C. Okay, I'm going to draw that. Please use a ruler when you draw. For the sake of time, I'm just rushing through this, but yeah, if you're concerned about neatness, yeah, please use a ruler. All right, so EBC sides are C, and this side is A, and this side will be a measure of CE because we don't know what this side is. All right, okay, moving on. We have triangle ABD, ABD. D, A, B here. ABD is your triangle, and here DB, we don't know because we know the whole length is A, but we don't know how much exactly is DB. So I'm just going to write measure of DB here. This length we know is C, and AD we know is H1, right? Yep. Oh, I'm sorry, I think I messed up here. This is actually H2. I see it here. H2, A, and C. So we know everything. Oh, sorry, this cannot be C because this entire length is C. So we don't know what is EB. So this I should have written as M of EB. That's, yeah, I missed that. I apologize. But this is measure of EB. And this will be H2, and then this is A. All right, moving on. Copy the laws. Law of sines, they are asking you to just copy the laws. So go ahead and copy these laws. It's the same thing. All right, simplify B and C using the law of sines. Given A is 30, B is 60, and the small alphabet A is 10. So 10 times sine B, which is sine 60. So what is our sine 60? I'm going to look at the unit circle again. Sine 60 here is square root of 3 by 2. Okay, square root of 3 over 2. And what is my sine A? My sine A here is 30. And what is sine 30? Sine 30 is 1 over 2. Now I'm going to divide this by 1 over 2. So when I do that, you know it flips over. The 2 goes on top. So this becomes 10 times square root of 3 over 2 times 2 over 1. So the 2 and the 2 cancel, and I'm left with 10 square root of 3. Okay. All right. Here I have A is 10. My sine C is sine 45, which is square root of 2 over 2 divided by sine A. Sine A is 30. Sine 30 is 1 over 2 again. So this is going to flip over when you divide two fractions. 10 times square root of 2 over 2, and then 2 over 1, because this flips over. These two cancel, and I'm left with 10 square root of 2. Let me check the answers. Yep, they're right. All right, that concludes our day 3, and tomorrow we will move on to day 4, which is our final day. I hope you guys have been enjoying these videos, and I hope it's useful to you all to make sense of what we're learning as far as trigonometry is concerned. If you do find them useful, go ahead and subscribe so that you'll be notified when a new video is posted, and also it would be an encouragement for me to keep doing these videos. All right, guys, thank you so much, and I'll see you in the next video. Bye.